So welcome to another Machine Monday. Today I wanted to take you to the process that we would go through if we were designing and building a non-contact laser measuring machine. So in front of me I have an example of one of these machines. It actually measures catalytic converters, both the ceramic brick, as well as the final assembled catalytic converter. More importantly, I want to talk through some of the features in this machine that are really critical to getting an accurate measurement out of the system. The first thing I want to discuss is actually the spindle. So what happens is you would put the part on top of this and we actually rotate the part and we move the laser measurement device up and down and we get basically different diameter profiles. So inside here is actually the spindle, and that's the connection between the driving pulley system and the actual tooling that holds the part. We have to get that as secure as possible to make sure we get the radial and lateral run out correctly, because you can imagine if we're rotating the part and it's not rotating around the center, we'll get inaccurate measurements. As well as if we rotate the part and we get this wobbliness, we also get inaccurate measurements. And so making sure we design and manufacture a very accurate, stable spindle is really critical to getting measurements correct. The second really critical part of the system is being able to position the laser in the right position in a linear way. So you can imagine as this laser goes up and down, we don't want it moving backwards and forwards, and we don't want it moving up in a wobbly way. And we have a fixture inside the system that prevents that. There's two main parts of this fixture. The first one is actually the linear rail. And as you can see inside the linear rail, as we assemble the linear rail, we have setting dowels that allow us to position the linear rail and measure the straightness of that linear rail before we tighten it down. And you can see inside the machine these jacking dowels, if you want, that are used to set the straightness of the linear rail. So once we've set the linear rail straight, what's important is that we position the sensor on the linear rail in such a way that it doesn't go wavy in that direction. And to do that, we actually have a set of three carriages that are set up in a way that preload each other, so we can actually set the system up so it actually goes up straight. So the positioning of the linear rail prevents the waviness in this direction, and the preloading arrangement we have with the linear carriages prevents this setting. And all of this is taken care of inside the system. And one really cool thing we've introduced into the system is actually self-calibration and verification. So obviously when you initially set up the system, you have to calibrate everything to make sure it's right. And so for what we've done is we've got these discs built into the system with known diameters, and we have at a predefined period. I think this particular machine does it every single morning. It actually goes in and does a self-verification against these discs. And if it's and if the measurements are not correct, it actually self-calibrates. And I think that's one of the cool features in highly automated production systems, that the systems are also self-checking. These are all the things that you have to get right in a non-contact laser measuring system in order to get accurate results. If you're interested in us developing a non-contact laser measurement system for you, please reach out.